Hello everyone. In this section we're going to look at our second problem. It's a car rental agency problem. The Save Us Car Rental Agency has 6 lots in Nashville, and it wants to have a certain number of cars available at each lot at the beginning of each day for local rental. The agency would like a model it could solve quickly at the end of each day that would tell it how to redistribute the cars among the 6 lots in the minimum total time. The travel times required to travel between the 6 lots are as follows, and it presents that information here to us. Now, one thing that's different in this situation is it hasn't given us all the information in one neat, simple chart. Instead, it gives us available and desired down here. The agency would like the following number of cars at each lot at the end of each day. Also shown is the number of available cars at each lot at the end of a particular day. Determine the total reallocation of rental cars. So what we have to do is we have to add available and desired to this table. Another word for available is supply. Another word for desired is demand. So what we do now is So what we're going to do now is we're going to recreate the table like this, including supply and demand. That's what I've done here. So we have from to number 1, we have the travel time to station 1. Obviously you can't travel. Number 2, 3, 4, 5, and 6, and the total number of cars available. We have the same information for each other lot, and that's what we've done here. However, and this is a mistake that many of you made, is you got this far, and you did a great job getting that far. But remember, with questions like this, what we have to do is ask ourselves, what are they asking? They're not saying 37 cars are available in lot 1, because they want 30 of them to remain there. So in lot 1 we have 30, but 37 are now available. So our actual supply in lot 1 is 7 cars. In lot 2 we have 25 desired, but only 20 are available. So our demand is actually, so it's not 7 and 30, it's 0 demanded, 7 supplied. In the second one, it's 5 demanded, 0 supplied. Because if we see here, they want 25, so they have 5 demand, but they only have 20. They can't give any more away. So that means, very simply, they have 0 supply. Go to number 3, they want 20, they have 14. So supply is 0. They cannot give anything, but they do want 6. Number 4, we have 40 desired, but 26 available. That means our desire here is 14 cars. They're very understaffed here. Over in number 5, we have 40 available, 30 desired, meaning they have 10 extra. And then our demand is 0 in that situation. And our final station, we have 30 desired, 40 available. 20 desired, 28 available. So the actual demand, I made a mistake somewhere. There we go. So here, the actual demand, there are 20 available, 20 desired, 28 available. So their actual supply is 8 units. and their demand is 0. So supply, all of this we receive from subtracting or comparing these two numbers. Once we've done that, we can create the actual supply and the actual demand. That's what we've done here. We've entered all of that data so that we could find what was actually available and it was actually demanded. Once we do this, it becomes a very simple problem. So let's solve it first in QM. We're going to open a module, transportation problem, new problem. We'll call it car rental example. We have 6 sources, 6 destinations, and it's a minimization. Now, one thing we have to remember is if a route is not possible, and sometimes they're not, but if a route is not possible, as we see here, 1-to-1, we just make this a big number so that the computer will not even consider it. We do that for each of the 6 impossible routes. Okay, and then we enter our relevant information. So 12, 17, 18, 10. Do it again. 14, 10, 19, 14, 10, 19. Move this over a little bit. So 12, 17, 18, 10, 20, 14, 10, 19, 16, 15. Repeating again, and this is repetitive, but there's nothing we can do. 10, 10, 12, 8, 9. Please bear with me. Number 4, 8, 16, 14, 12, 15. Almost there. Here again, source 5, 11, 21, 16, 18, 10. And our final one, we have 24, 12, 9, 17, 15. So we've entered all of our relative data. Remember, the original goal of this was to provide the car rental place with a model where they would never have to change anything serious. They would make minor adjustments every day. That's what we've completed right now. We've completed a situation where they will, if they keep this information in here, only have to adjust demand, only have to adjust supply, depending on what is available and what is desired at the lot each day. So let's add our current numbers in. We'll make demand 0, 5, 6, 14, 0, 0, and again 7, 10, 8. We see here that 25 are supplied, 25 are demanded. So this is a balanced equation. All we have to do is hit solve, and we see here that the total time traveled is 364 minutes. In source 1, 7 were supplied. 7 were supplied. Source 2, 0 supplied, 0 supplied. Source 3, 0 supplied, 0 supplied. Source 4, 0 supplied. Source 5, 10 were supplied, 10 were used. Source 6, 8 were supplied, 8 were used. Let's go the other way and let's look at our total demand. Number 1, 0 demanded. They received 0. Number 2, 5 were demanded. They received 5. Number 3, 6 were demanded. 6 were received. Number 4, 14 demanded. 14 received. So this is our solution. Once we calculate what actually is demanded, this is a very straightforward, easy solution. Hopefully everyone is clear on that. I'm not going to solve it in Excel because at this point, you should be very comfortable with Excel. Next class, tomorrow, we will do 2 things. I will present one situation that will be added to your final exam, and then I will also give you a brief midterm exam review. Thank you everyone for listening. See all of you in tomorrow's class. Hello everyone. This is our second last session. We have one more class tomorrow, and then our midterm exam is 1 week later on Thursday of next week. Now, what we're going to do is we're going to look at 2 problems that appear to be very straightforward, but had a few complications, so they were a little more difficult. The first one is a military example. During the US military action in the Middle East, large amounts of military material and supplies had to be shipped daily from supply depots in the United States. The critical factor in the movement of these supplies was speed. The following table shows the number of plane loads of supplies available each day from each of the 6 supply depots and the number of daily loads demanded at each of the 5 bases in the Middle East. A key point to consider in this question is, what are they asking? They're telling us, and we're going to look down here. We have supply depot 1, 2, 3, 4, 5, 6, and military base A, B, C, D, E. We know the key is from supply depots. So we're shipping from America. One thing we have to consider is this a balanced or unbalanced question? Meaning, if it is balanced, there is exactly enough for supply as there is for demand. If it is unbalanced, either supply or demand is unequal. So in this situation, let's count up our supply. Here we see supply is 7, 17, 25, 33, 42, 48. We see 48 units are supplied. So we wrote that down here, 48 units supplied. How about demand? We have 9, 15, 27, 35, 45. We have 45 units demanded. So we have 48 units supplied and 48 units demanded. What we have to do then is solve knowing it's unbalanced. In this situation, because we have more supply than demand, all of our demand will be met. But also because we have more supply than demand, we know that in this situation, we will have 3 leftover units. And what that 3 leftover units means is we will be in a situation where 3 units will have to be abandoned. We will ship only 45 because only 45 are demanded. Let's go to QM and see what happens. We open a new module, transportation problem. We open a new file. We check our, let's minimize this. So we see that we have 6 sources. Let's call it the military problem. We have 6 sources, and we have 5 A, B, C, D, E, 5 destinations. We hit OK. So here we have destination A, B, C, D, and E. We have sources 1, 2, 3, 4, 5, and 6. Now, as we can, from now, using QM, this will be pretty easy. We can solve this relatively simply because QM does the work for us. So let's enter our information, 36, 40, 32, 43, 29, with a supply of 7. 2 is 28, 27, 29, 40, 38, with a supply of 10. Supply depot 3 is 34, 35, 41, 29, 31, and our supply is 8. Number 4, go down here, 41, 42, 35, 27, 36. The supply of 8. Number 5, we have 25, 28, 40, 34, 38, with a supply of 9. Number 6, 31, 30, 43, 38, and 40, with a supply of 6. The only thing we have to do now is enter our demand. 9, 6, 12, 8, and 10. Because QM is hyper capable of simple problems like this, it will automatically assess if there are any extras or any deficiencies. If there are, as we've seen before, it will create a dummy account. So let's hit solve and see what happens. Here we see a dummy account with 3 units. We knew we had 48 units available, but only 45 demanded. We knew 3 were going to be extra. Everything looks okay so far. So supply depot A, 7 were supplied, 7 were supplied. 10, 10. 8 were available, but only 5 were used, 3 were thrown in the garbage. 4 is 8 available, 8 were shipped. Number 5 was 9 were available, 9 were shipped. And the last one, 6 were available, 6 were shipped. Did we fulfill all the requirements? A was 9, A 9. B6, B6, C12, C12, D8, D8, E10, E10. So this information shows us that we're probably correct. It looks like it's 1,275 hours to reach all of these supplies in the Middle East. Now, one thing that we see here is that there's 0 and 10, 0, 5, 9, 0. What this means is that the computer has attempted to use these, but there were no more left. So it inputs the number 0, even though it doesn't do that for all of them. So thank you. That is how we solve this problem in QM. Let's solve it one more time in Excel. So we're going to make our cells smaller with a couple being bigger. So let's add that for now. Military example again. Now, as before, we first want to show our situation with decision variables. So we make this supply, base, A, B, C, D, C, D, and E. Supply 1, 2, 3, 4, 5, 6. All of this information will remain empty because these are decision variables that the computer will compute for us. But we do have supply, and we see supply is 7, 10, 8, 8, 9, 6. We're going to do it one more time. This is demand. We have 9, 6, 12, 8, and 10. So we add, demand is also the same as received. This is how much they want. Received is how much they get. So equals sum of these numbers. Hit enter. Right now it is 0. We're going to fill right. Supply is also the same as shipped. So we have equals sum of these 5 rows. Hit enter, and we fill out. Okay, that's our base information. This is where we've represented our decision variables. Now we come over here and we're going to do it one more time. We'll call this base. Supply A, B, C, D, E, 1, 2, 3, 4, 5, and 6. Now here, all we do is enter our relevant information. So please bear with me. 36, 40, 32, 43, 29, 28, 27, 29, 40, 38. Number 3, we have 34, 35, 41, 29, 31. 4, 41, 42, 35, 27, 36, 25, 28, 40, 4, 38. And this is annoying, but it is important because if you make a mistake, your answers will be off. 31, 30, 43, 38, and 40. So we've essentially completed all of the information we need, except for one thing, which is total time. And we're going to use an array system equals sum product B4 to B9 multiplied by L4 to P9. We close our formula and we hit enter. So this is the problem correctly formulated. We have a couple minor complications when we get to our solver, so let's go there. Data, solver. As always, we adjust our set objective is to determine the total amount of time. We're minimizing because it's a transportation problem, and we're changing these cells, B4 through F9. That is what the computer is going to run permutations of. So we hit simplex LP, and then we add two constraints. The first one, the total shipped must be less than or equal to the total available. If we ship the total available, if we ship 45, we're going to send too many. If we ship the total available or more, we're going to ship if we ship the total available, if we make this equal, then we're going to ship 48. We don't need 48. If we make this greater than or equal to, it's 48 or more. We don't need 48 or more. We need less than or equal to 48. We hit OK, or we hit add. In the second section, the total received must be equal to the total demanded. We hit OK. So now we see less than or equal to and equal to because we have more of one and we require less of that. So let's hit solve and see what happens. Solver found a solution. All constraints and optimality conditions are satisfied. So let's hit OK. We see here 7 were supplied, 7 shipped, 10 supplied, 10 shipped, 8 supplied, 5 shipped, same as we saw last time. And again, these are all equal. All of our demand was satisfied, and it will be because we're throwing 3 in the garbage, we will have the exact same total as we had previously, $1,275. Thank you everyone for listening. In the next section, I'll solve the second problem.